Hello friends, welcome to my channel. Let's have a look at problem 2487, remove nodes from linked list. In this video, we are going to share two solution formats. So one format is in a verbose way, and the other actually is a rework of the first format, but we are going to use in-place operations. First, I'm going to read through the problem statement to digest the requirement, and then we do the analysis and share the codes. First, let's look at the problem statement. We are given the height of a linked list, so remove every node which has a node with a strictly greater value anywhere to the right side of it. So return the height of the modified linked list. So here are two examples. So example 2 is special because all the numbers are the same. So we are going to return the original linked list. For the first example, so if we reverse look at the linked list, so actually we are going to maintain a monotone non-decreasing sequence. So for example, 8, 13, right? So it's so this is also our way to treat this problem. So before we look at the analysis, let's also look at the constraints. First, the number of nodes in the given list is in the range 1 and 10 to the power 5. So in particular, this original list is not null. So secondly, the node value is bounded below by 1 and bounded above by 10 to the power 5. So with that said, we are ready to do the analysis. So for this problem, actually, the operations we're going to carry are actually routine. So in the two formats we are going to present, for the first format, it's actually a verbose way. So we are going to do the following steps. First, we're going to get the corresponding list of the linked list. So this way, so we finish the first step. In the second step, we're going to reversely iterate over the list and then maintain a non-decreasing stack. So step 3 is to build the linked list. So here is an example walkthrough. For example, we are going to use example 1. So if we know the height of the linked list, we can do a traversal to get the corresponding node values. That is the corresponding number list. So this is the number list. Then in step 2, so we can initialize a stack by S. Then we iterate reversely the list. So if stack is empty, we just push the element to stack. If the stack is not empty, then we ignore the element if it's smaller than the top element, right? Otherwise, we put the element to the stack top. So this way, the stack will be non-decreasing. So for example, for this example, then we first look at for index 4, so we have s equals 8. Then we look at 3. 3 is less than 8, so we continue. So in this step, so s is still contains 8 only. So when we look at the second index corresponding to 13, so 13 is no less than 8. So we append or push stack 13 to the stack top, so we get 8, 13. Then similarly, we look at the number at index 1 and index 0. So they are both less than the stack top element. So we just continue. So finally, so we reverse the resulting stack, that is 13, 8 after reverse, and then we build a linked list with this node values. So this is going to be our return. So this way is actually very easy to understand. So it's also very easy to operate, but this actually we use some rebuild. So in the second format, we are going to do in-place operations. So for this method, the idea actually is the same as the first method, but what we need to know is how to reverse a linked list and how to delete specific nodes. So these tasks are actually some basics. So here we essentially do the same thing as in format 1, but use in-place operations. So with that said, let's do the job first. So in the first version, I'm going to do it in a verbose way. So also we are going to practice using the list traversal, linked list traversal, and using monotonic stack. We can see it's a monotonic stack, but it's just to get a non-decreasing sequence in a reverse order. So now let's first use aux. So for this, so to hold the values. So then also I want to count the list if I like. So this is not necessary. So let's maybe do this. So 0. And then what we are going to do, while head, what we are going to do is to append this value to the aux. So aux append head value. So in this case, once we add this one, so we're going to increment the index by 1. So this means that we add an element corresponding to index 1. So actually, we can also store the index. So if we append, we do append, so head value at index. So this way we are going to know which index to be removed, but we are not going to do that. So here, then this index will just keep a length of the linked list. So with that done, so we can set the head to be head next, right? So once we exit this while loop, so actually we get the corresponding value list for the linked list. So then the IDX will be the length of the linked list. You can print it out, so just to examine. For example, for this first one, the length is 5. So let's check that. So this is 4. So let me see. Let's see. Index plus 1. So here IDX. Yeah. So here's right. So this the last index is 8, right? So we're going to have this one. So with that done, so let's see if head is still so it should return 5, I guess. So let's see, print it out. Oh yeah, so this is 111. It's a different example. Now let's check this example. It should return 5. So the reason is that once we get 8, the index is 4, so we still increment by 1, right? So the length is the largest index plus 1, so this is right. So with that said, so actually we introduce this variable, just this n is nothing but the linked list length. And then we can iterate reversely. So we are going to maintain a non-decreasing stack. So here I'm going to use stack. Let's see. Step 1, get the value list. Step 2, maintain a non-decreasing stack. So due to the requirement or the here, so we are going to iterate the value list reversely. So for I in range n-1, so up to -1, so -1 is not included. So for this, so if not stack, so I'm going to do stack append the aux I. So this is the one. Otherwise, so we're going to compare the current element with the stack top, right? If aux I, so it's if it's less than stack -1, then in this case, so we just continue. Otherwise, so the current number we're looking at is larger, so no less, or we can see. So we're going to append this one. This way, we're going to get the corresponding values after deletion, but in a reverse order. So let's print this out. So stack. Yeah, we're going to get 8 and 13, right? So next, we're going to build the return. So for this, I'm going to do a reverse. So let's do this. So I'm going to introduce a dummy variable. So let's call this node. So because the value is in between 1 and 10 to the power 5, I can use 0 just to distinguish. So it's not necessary to use 0. You can use any one. So like 1 or 2 or something. So then we are going to set the current to be dummy, right? So what we are going to do is that while stack, and then we are going to first get the value, right? The value is a stack pop. So, and then we are going to make a temp list node. So the value is going to be the value. So you can write into one line, just use this value equals stack pop. But let's write this to make the idea clear. And then what we are going to do is to set the current next to be temp. And then what we are going to do is move forward one step to current to be temp. So after this, so we finished build the linked list. So because we are using stack, so we have also reversed the list. So then we are going to return a dummy next. So this dummy node actually plays a role. Or you can choose not using this dummy node, but this brings us some convenience. So this is one solution. So in this solution we have 3 steps. So one is to get the value list, and then to maintain a non-decreasing stack, or you can see it's a monotonic stack, but it's just different flavor, I would say. And thirdly, so we build the return. So at this stage, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is the one solution. So in this solution, the purpose is to help us gain some intuition. So now let's copy this function signature and then write another solution format using in-place operations. So I'm going to change this one to be v1. And then I'm going to change this one to be v2. So here, what I'm going to do is to use in-place operations. So for this, we need to do some reverse of the linked list. So this actually provides us a good practice. So first, I'm going to reverse the linked list so that I can iterate conveniently, right? So this is actually simple. So previous is none. So let's use a previous as a list node, and then current is the current height, and then we are going to do the reverse operation. So while current. So what we are going to do is first we are going to get the follower of the current next. So and then we are going to break the link, right? We are going to set the current next. So it's not going to be the original next, but the previous, right? And then what we are going to do is to set the previous to be current, and the current to be the follower or the next of the original current. So this way, so actually we finished the reverse of the linked list. So actually, because of the way we write the code, so once we exit this while loop, and then the current will be null, and the previous will be the last node if there are in the original linked list. So in other words, so new height will be previous. So this new height will be the reverse linked list. So you can print this out just to check, make a check. So let's use this example for the check. Right? So we're going to have 8, 3, 13, 2, 5. Right? So this is the first step. So let me delete this one, and then let's do the second step. So for the second step, we are going to do the removals. So this is simple because we have reversed the linked list. So we just need to linearly traverse the new head linked list. So once we have a value which is larger than the previous value, we are going to ignore that value, right? So this way we are going to maintain a non-decreasing linked list. So this is also very simple. So I'm going to use a dummy index. So it's list node. So I'm going to use a value to be 0, and then we are going to connect it to next to be the new height. So the reverse linked list here. And then we are going to do the removal. So for this, I'm going to set the previous to be demo, and the current to be the new height. And then we are going to iterate using while loop, while current. And then we are going to check the current value with the previous value. So here, for this to be work, we want to use a smaller value, so less than or equal to 1. So here I'm using 0. So this should be no larger than the smallest value. So this is a small detail, right? So then if current value is larger than the previous, larger than or equal to previous value, what we are going to do is that we are going to move forward one step. We are going to set the previous to be current and the current to be current next. So this is an easy one. So there's no deletion operation or removal operation. So next, if the current value is strictly less than the previous value, then we're going to ignore this current, right? So this actually corresponds to, let's first introduce a temp to be the current next, right? And then we're going to do previous next to be the temp, right? So originally previous points to the current, but now we point to the current next, and then we are going to set the current to be temp, right? So this way actually corresponds to, or in effect, removing the current node. So once this done, so actually after we exit this while loop, so the current will be null, right? And then the list will be corresponding to, so let's say, the reversed linked list. So it corresponds to dummy next, right? And then what we are going to do is to reverse back, right? So now it actually corresponds to the first format of solution. So let's do a reverse again, reverse back. So because we used twice of the reverse, actually we can write a utility or hyperfunction to do this reversal. But now let's do it here. It's because it's so simple. So previous is now, and the current is the reversed linked list, right? So while current, right? And then what we're going to do, first we get the follower of the current, that is current next, and then we break the link current next. Let's point out to the previous, right? And then we are going to set the previous to be current and current to be temp. So the temp is the follower of the original current. So this way, so we reversed the linked list. So notice that, so because of the way we write the code, so after we exit this while loop, the current will be null, point to null, and the previous will be the one we want to return. So we are going to return previous. So the current state of the previous is what we want to return. So let's do not introduce more variable. So actually I would prefer to let result equals previous and then return result. So but let's keep this. So this finished the second solution format. You know, it's in a very modularized way. So if you compare with the first solution format, step 1, reverse the linked list. So this is to get the corresponding values corresponding to the first format. The second format is do the removal. So this way, actually, in effect, this is the else block, right? So in the first format is the monotonic stack operation. So then we do the reverse again. So up to now, I guess it's a good position to check for some test cases. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. Yeah, I guess that's about it for this special problem. So you're welcome to practice or examine the solutions and make comments, or you can check some other videos in the playlist for linked list or other videos in my channel. So with that said, I guess that's about it for this video. Thank you.